horizontal motion. That means horizontal projection, which means said to be the horizontal projection mean the angle of projection is zero. The angle of projection is zero. So horizontal projection, if we ignoring air resistance, then there are no horizontal force act on the projectile, no horizontal force, no drafting force, or no motive force can be acted on them. This means there is no acceleration in horizontal projection when to be ignoring air resistance. So the velocity stay the same horizontally, which mean what? Horizontal velocity is constant, that is Vx. Horizontal mean x, Vx is constant. The horizontal velocity, x mean horizontal, the vertical mean y. So horizontal displacement or horizontal velocity mean Vx, that is constant, and the vertical initial velocity is also what? Zero. V naught y is equals to zero. Vertical initial velocity, which means the angle is zero, or have no acceleration horizontally. Therefore the vertical acceleration is 9.81, that's the gravity, and so the only factor that affecting the time, the flight time to hit the floor is the drop height. This is the factor of the flight time, is the only what? The height. Okay, so the gravity constant. We can use the following equation to be what? Drive here these concepts. First, what? The motion equations are displacement is equals to average velocity times time taken. S is equals to V average time T. Here V average mean the velocity or the motion is horizontal, therefore the horizontal velocity is constant, which mean average mean V1 plus V2 over 2. The two values is constant, then have the same values, which is Vx. Here horizontal displacement mean range in a projectile, horizontal motion range. The horizontal displacement or range is equals to horizontal velocity times flight time. Here the horizontal velocity is Vx. X is equals to Vx times t. Here Vx is average velocity. The average velocity and the individual velocities, x velocity, is constant. So x is equals to Vx times t. So the flight time is given by the equation of the vertical motion equation, that's a uniformly accelerated motion equation. So displacement, vertical displacement, or y is equals to v naught yt plus half of gt square. So here looking vertically, v naught y means 0, v naught y here 0, because projection is horizontal, there is no vertical motion, or there is no vertical velocity at initially. So within magnitude of t, so the value of 0 times t is 0. So the equation become here 0. The remaining one is half of gt square, that is y, or vertical displacement. So use crisscross to be getting t. The flight time t is equals to under root of what? 2 times y over g. G is gravity, and twice of y mean y is the vertical displacement. So we'll come back to this. Okay, here is the horizontal displacement that increasing up to 10, 12, 14, 15. Okay, and here the zoom 15, and when it is 0 mean horizontal projection. Let to be a football the football projection within, assume 5 meter per second. Let increase out to 10. Oh, it increases, again within 50. Okay, it increases again. Okay, welcome to 50 and 20, 15 to 20. Oh, it's far, it's so far. Okay, here mean in 20 meter per second the football reach 34.7 meter per second. To increase again velocity by 5 and throw it. Wonderful thrown that at the initial velocity that is 25, and again 13. Here the last effect. 43 meter and 52 meter. Here decided what? At a constant height, to be increasing the velocity, we increase the range. The range is increases, and we'll come back to the vertical decreasing or increasing, and change the vertical displacement. Let's start again at a constant, let to be constant velocity, initial velocity, at horizontal velocity. Here mean how much is I0 digital one. Okay, the range is 26.23 and the time 1.75 seconds is the flight time, and let decrease with 1 meter, that's 40 meters, decreasing by 1 meter. So again 1.69, the flight time also decreases with decrease time, the height, and also decreases the height 40 up to 10, and again the time is decreases also, and the range also decreases. Again decrease the height, that is 5 meter above the earth surface, and the flight time is also what decreases, and again 3 meter. Okay, also the range and the flight time also what decreases, also nearly 2 meter, that is the height of the man project, and okay, nearly also the range 9.58 meter, and the time, the flight time, that is 0.64 seconds. This is all about the projectile, that horizontal projectile. Again come into the height of 50 meter, and let to be change the human, and the velocities component. Okay, here the component of velocity, let us slow. Here is the total velocity, and this one is horizontal velocity, here one is vertical velocity. Okay, this one is total velocity, the sum of the vertical and horizontal velocities, total velocity. here vertical velocity and here horizontal velocities vx. This one is vx and this one is vy. Okay, here increasing, vx is constant. Later again here vx is cannot be changed. Okay, the magnitude of vx is constant, but vy is, okay, it increases randomly. Okay, increases repeatedly, increase, you know, here. Okay, in horizontal velocity vy is change, it does change. Okay, again to be see the acceleration, you know, the acceleration in horizontal motion is constant. Okay, it cannot be what change, that is constant, which is 9.8 meter per second. 9.8 meter per second. Okay students, this is dramatically the boy is project. So this is the component, the only one component is of the acceleration, that's the vertical acceleration, vertical one, and the components of velocity. Here the total velocity, that is the sum of the vx and vy, sum of vx and vy, this is vx and this one is vy. So the total velocity is equals to under root of vx square plus vy square. So vy mean vertical velocities at a point here, also here, and vx mean that is constant at any time, any point. Then to be squaring them, it to be get the total velocity here. Oh, thank you. This is all about horizontal projection. Thank you. Let to be subscribing in YouTube. Zalot Studio channel is your favorite YouTube channel. With